The Kalashnikov concern, Russia's largest small arms manufacturer, now markets itself as a modern lifestyle conglomerate. In an attempt to rebrand their flagship rifle, the company produces slick marketing videos describing the gun as a weapon of peace, while selling a line of branded apparel and consumer accessories. This polished corporate image obscures the grim conditions of the rifle's birth. In 1941, a wounded tank mechanic named Mikhail Kalashnikov lay in a crowded field hospital, listening to soldiers complain about the failure of their equipment. Their standard-issue rifles and submachine guns were prone to jamming in the brutal environmental conditions of the Eastern Front. Kalashnikov set out to design a tool for the defense of the fatherland. His vision was specific: a weapon cheap enough to be mass-produced at minimal cost and simple enough to be used by a conscript with no formal military training. Today, the company promotes a sanitized myth of a lone, self-taught inventor. However, the true history of the machine is a much messier story of borrowed concepts and a collaborative engineering team working under intense wartime pressure. Following a series of failed design trials in 1946, Kalashnikov was reluctant to change his initial prototype. He only overhauled the weapon after intense pressure from his assistant, Alexander Zaitsev, and his wife, Katya, who urged him to simplify the design to improve its reliability in environmental testing. This image shows the German STG-44, the world's first widely fielded assault rifle. Kalashnikov's team studied this design closely, adapting the concept of the curved 30-round magazine and the stamped metal receiver, the outer housing that holds the internal components, to facilitate faster production. For the internal firing cycle, they turned to the American M1 Garand, the standard-issue semi-automatic rifle of the U.S. Army. The team adapted the Garand's gas-operated system, using a gas cylinder and an operating rod beneath the barrel to cycle the weapon's action. By 1947, the design had evolved into a new prototype. They combined the upper and lower receivers into a single unit and implemented a long-stroke gas piston above the barrel. This simplified the production process and reduced the number of separate parts that could fail in the field. The finalized mechanism relied on only 8 moving parts and used a rotating bolt. When a round is fired, the gas drives the piston back, which rotates the bolt approximately 35 degrees to unlock it, eject the spent case, and chamber a new round as it locks into the barrel. Unlike more sophisticated rifles, the AK-47 utilized massive internal clearances and dirt grooves. Instead of trying to seal the weapon, these gaps allowed mud, sand, and carbon fouling to simply fall away from the moving parts, ensuring the gun remained operational in the harshest climates on Earth. This lethal simplicity was not a sudden epiphany. It was a forced, iterative evolution that synthesized the best existing technologies into a single, soldier-proof package. Manufacturing the weapon proved much harder than designing it. The first production models, the Type 1, utilized a stamped sheet metal receiver that was supposed to be cheap and fast to build. Instead, the high rejection rates of warped and unusable parts nearly halted production entirely. To keep the Soviet Army supplied, the factory reverted to a much slower and more expensive process. For years, they manufactured the Type 2 receiver by milling heavy, solid blocks of steel into shape, a method that ensured durability but sacrificed the goal of cheap mass production. Reliable mass production wasn't achieved until 1959 with the introduction of the AKM. This modernized variant finally perfected the stamped steel receiver, drastically reducing the rifle's weight and making it one of the most cost-effective firearms ever made. This standardized simplicity allowed the Soviet Union to treat the rifle as a disposable item. Rather than establishing complex repair depots and logistics chains, military doctrine focused on replacing the entire weapon whenever it was damaged or exhausted. Cold War military aid seeded millions of these disposable rifles into global insurgencies and irregular forces. Because the gun was so easy to maintain and operate, it became the primary instrument of conflict across the developing world, reaching regions where traditional military supply chains could not function. The rifle became a global icon of revolution, eventually finding its way onto national flags and coats of arms. In Mozambique, the weapon's distinct silhouette is woven directly into the fabric of the state, serving as a permanent symbol of the country's struggle for independence. The AK-47's ultimate weaponization was its logistics. Its cheap, reliable production turned a simple tool into a geopolitical force that could be distributed as easily as a common commodity. Late in his life, Mikhail Kalashnikov expressed deep spiritual regret over the deaths caused by his invention. The modern Kalashnikov concern, however, has pivoted toward the next generation of warfare, expanding its portfolio far beyond handheld rifles. This shift is visible in the company's move toward unmanned systems, such as the Lancet loitering munition shown here. By diversifying into drones and guided missiles, the conglomerate is attempting to survive international sanctions and adapt to the requirements of modern electronic warfare. Through the Archangel project, the company is now industrializing grassroots technology. They are mass-producing volunteer-designed drones that have already been combat-tested in the trenches, folding civilian innovation directly into their formal production lines. The 1940s relied on heavy tooling and centralized state prototypes, but the 2020s rely on agile digital blueprints. New drone variants move from volunteer workshops to factory assembly lines in months rather than years. Despite the shift in technology, the underlying philosophy remains identical to the 1947 breakthrough. The concern prioritizes extreme simplicity and field-tested reliability, producing at a scale where every unit is disposable. This legacy offers a brutal blueprint for modern warfare. Dominance in a war of attrition belongs to the side that identifies a lethal, simple baseline and manufactures it faster than the enemy can destroy it.